In this video, we are going to talk about valency. What do you know about valency? Valency is the combining power of an element. It is also the number of electrons in which an element gains or loses in order to achieve stability. For example, let's check the valency of chlorine. Chlorine has 17 electrons. So drawing the structure, the first shell will contain 2 electrons. The second shell will contain 8 electrons. Remaining 7 because we have represented 10 here already. So the last shell will contain the remaining 7. So 1 will be here. So this is the structure of chlorine. Then we need to note that for an element to be stable, it must have maximum of 8 electrons. In its outermost shell. For chlorine to be stable, it will have to gain 1 electron in order to complete its outermost shell, 8, or it will lose all these 7 electrons. So that this one will be the outermost shell having complete 8 electrons to make it stable. So we have also to note another thing. Another thing we need to note is that any element that has from 1 to 4 electrons in its outermost shell, we have to lose those electrons, as in we have to donate them. But any element that have from 5 to 7 electrons in its outermost shell, we have to gain more electrons in order to be stable. So chlorine is under this category. So it will have to gain 1 electron in order to be stable. So since chlorine have to gain 1 electron in order to be stable, its valency is now 1, as we define valency as the number of electrons in which an element gains or loses in order to be stable. Let's look at another example here. Let's look at sodium. Sodium has 11 electrons in its outermost shell. So let's draw the structure. The first shell containing 2 electrons. The second shell containing 8 electrons. Remaining 1 electron. So this outermost shell will bear the remaining 1 electron. So sodium here requires 7 electrons in order to complete its outermost electron. 8. That is in order to be stable. So sodium will have to remove this 1 electron so that it can be stable. Or it will have to gain more 7 electrons in order to be stable. We know that from 1 to 4 we lose their electron, but from 5 to 7 we gain their electrons. So since like this, sodium is under this category. So sodium will lose its 1 electron in order to be stable. So this 1 electron it will lose is now its valency. So valency of sodium is now 1. Okay, let's go into another example. Let's look at aluminium. Aluminium has 13 electrons. So let's draw the structure. First shell will contain 2 electrons. second shell will contain 8 electrons. Then the last shell will contain the remaining 3 electrons. So here aluminium needs more 5 electrons in order to be stable. So it will either get more 5 electrons or it will lose this electron, making this shell here its outermost shell. From this, aluminium will lose its electron because it's under this category. It will lose these 3 electrons in order to be stable, making this shell here its outermost shell. It will have to lose these 3 electrons, making its valency 3. Let's look at another example. Oxygen. Oxygen has 8 electrons in each shell. Let's draw the structure. First shell containing 2 electrons, remaining 6 out of the 8 electrons. So this second shell will bear the 6. Oxygen requires 2 electrons in order to be stable. It will have to gain more 2 electrons to be stable. So it is under this category. So it will have to gain 2 more electrons in order to be stable. Its valency is now 2. That's it for this video. Thank you for watching.